Question. Angle AOM equals 12 degree. A light ray shoots from point A to point T on the edge of OM and then reflects to OA. After multiple reflections, when the light is perpendicular to one side, it returns to point A along the original path. Find the minimum value of angle TAO. Okay, let's think about it. The light described in the question starts from point A, but we don't know the specific degree of the angle TAO, nor do we know how many times the light will reflect inside the structure and then return. The conditions of the question seem to be too few, so few that we can't start. So what should we do? You must learn a way of thinking to solve such uncertain mathematical problems, which is to start exploring from the simplest situation. Let's look at case 1. The light starts from point A, is reflected by OM, reaches OA, and is exactly perpendicular to OA. The light will return to point A along its original path. This is the simplest situation. As shown in the figure above, let the angle AOM is equal to alpha, and the angle TAO is equal to gamma. In the right triangle THO, beta is equal to 90 degrees minus alpha. Let's look at the triangle TAO. According to the triangle exterior angle theorem, beta is equal to gamma plus alpha. So we get the equation, 90 degrees minus alpha is equal to gamma plus alpha. So the angle TAO, which is gamma, is equal to 90 degrees minus 2 alpha. Let's put this on the right side first. Next, let us take a small step further and look at the situation of 3 reflections. As shown in the figure above, the light now has one more reflection than case 1. In the previous deduction, we already know that gamma is equal to 90 degrees minus 2 alpha. In the triangle TAO, similarly, according to the triangle exterior angle theorem, gamma is equal to delta plus alpha. So we get the equation, 90 degrees minus 2 alpha is equal to delta plus alpha. So the angle TAO in this case, which is delta, is equal to 90 degrees minus 3 alpha. Let's put that on the right side. Going one step further, let's look at the case of 4 reflections. As shown in the figure above, the light now has one more reflection than case 2. In the previous deduction, we already know that delta is equal to 90 degrees minus 3 alpha. In the triangle TAO, in the same way, according to the triangle exterior angle theorem, delta is equal to epsilon plus alpha. So we get the equation, 90 degrees minus 3 alpha is equal to epsilon plus alpha. So the angle TAO, which is epsilon, is equal to 90 degrees minus 4 alpha. Let's put that on the right side. In fact, we can continue to deduce, but this is unnecessary. From the above conclusions, have you discovered some rules? Great! You've summarized the equation for the general situation. That's right. When the number of reflections is n, the angle TAO is equal to 90 degrees minus n alpha. So how does this help us? Here's the key step. For the light to reach OM, then the angle TAO must be greater than 0 degrees. So we get the inequality, 90 degrees minus n alpha is greater than 0 degrees. It is known that alpha is equal to the angle AOM is equal to 12 degrees. So 90 degrees minus n times 12 degrees is greater than 0 degrees, and the solution is that n is less than 7.5, and n is a positive integer. So the maximum value of n is equal to 7. The minimum value of angle TAO is 90 degrees minus 7 times 12 degrees, which equals 6 degrees. Now we finally get the answer. One more thing. I'm going to show you how the light is changing in this structure. I will simulate the angle TAO reducing, and you will see how we increase the number of reflections and still get the light back from the original path. When the angle TAO is less than some amount of degrees, it is not possible anymore. This is the Geo-Thinking channel. Thanks for watching. If you like my channel, please like and subscribe.